Hi, everyone, and welcome to Backer Breaks It Down. In this episode, we are going to explore some proportionality theorems, specifically the Angle Bisector Theorem. So, in this diagram, you are given that ray CA bisects angle GCF, okay? And so recall that when we bisect an angle, the results are two congruent angles, which they have marked for us. We know that angle GCA is congruent to angle FCA, okay? But look at various segment ratios, because there are 4 segments that they've given us the measures of. What do you notice? What do you wonder? So I'll tell you what I notice. I notice that some of these ratios are actually equal to one another. So the one I have in blue, both of these are equal to 10 over 7. Okay, so notice I had one ratio came from 10 and 7. The other one was 4 and 2.8. So I kind of took the sides of the triangle over those corresponding segments that they made. Whereas the one in green, I have, let's see, the 7 over the 2.8, these are the segments, and the 10 over 4 are the two sides of the triangle. So I'm just kind of noticing that some of these ratios are equal to one another. And you know what that means? It means they're proportional. And so the angle bisector proportional side theorem says a bisector of an angle in a triangle divides the opposite side into two segments whose lengths are in the same ratio as the sides adjacent to the angle. So the opposite side has been divided into two segments. So we're talking like AD and DB. Okay. And those lengths are in the same ratio as the sides adjacent to the angle. Okay, so that would be side like AC and CB. So we can create a proportion that shows this. So notice they have AD over DB. Those are those segments. And CA over CB are the sides. So you can have the segment ratio equals the side ratio. Just don't go twisting these things together because this side and segment, they're like a duo. Same with these two. So don't go twisting them up, otherwise this isn't going to work, okay? But we can have a segment ratio and a side ratio. And so here we have an example. They created, so their proportion, notice what do they have on top? 3x and 2x plus 6. Those are both the sides. So they have sides on top. And on the bottom, the 9 and the 15, those are the segments. And I don't know if you noticed this earlier, but I created two proportional relationships in our introduction, and one of them was side over segment. That's how I wrote my ratios, was side over segment. Whereas the one in green was segment ratio equals side ratio. So there are 2 ways you can go about setting these up. Honestly, it's what occurs to you when you're looking at your diagram. I kind of like the side over segment because honestly, you can see these ratios when you look at the diagram. They're right there. Yeah, they're right there. The bottom line is they are in a proportional relationship. So as long as our proportion is set up properly, it's all good. So they went the side over segment route, and they ended up getting the x is 2. Okay. So if we look here, I have an angle that's been bisected. So that means the two segments form a proportional relationship with those two sides. We want to be careful here because they're saying like this whole side is 3x plus 7. But the way my proportion works is I need to use the individual segment. So I have to be like, what is this? Okay. And so that segment right there can be found by taking the whole segment, 3x plus 7, and subtracting the part that I know, so minus 20. And that will give me just that segment. So we're looking at 3x minus 13 is just that segment. Okay. And then I can write a proportion. So I can do like 3x minus 13, sorry about that, over 10 equals like 20 over 25. That's a possibility where I do like segment over side equals segment over side. I can do like my segment ratio. So 20 over 3x minus 13 is equal to the side ratio, 25 over 10. So either one of these proportions would work. Notice the cross products are the same, and that's like why they work. Okay. So yeah, there are two ways that I can create these proportions, but because like of that proportional relationship, it all works out because the cross products are still going to be the same. And so this is ultimately what I ended up getting here. I ended up getting x equals 7. Okay. But we can set up our proportion using like one of two like setups. So you can do like the segment ratio equals the side ratio. That's one way of setting up these types of problems. Or you can do like segment over side equals segment over side. Okay. Just don't go twisting the segments and sides around. So like this side goes with this segment. This side goes with this segment. Okay. But that's your Angle Bisector Theorem, and that is how Backer breaks it down.